Hello everyone, Future Coder here. So before we get into today's video, I just want to give a shout out to a good friend of the channel, Engineering Scale Models. Engineering Scale Models, or Jason, which is his real name, is a very active member of the community and a very good friend of the channel. He's sponsored the channel before by sending us gifts, and I want to do him a favour by trying to get him to 1,000 subscribers on YouTube. And the reason for that is not because you can monetize at 1,000 subscribers, but purely because he wants to be able to get the community tab. And he wants the community tab option so as he can post links to all of the files that he's making based on the Nintendo Switch, such as the pinouts for the USB-C port and all of the diode readings for all of the chips and things like that. So if we could get him to 1,000 subscribers so as he can actually use that feature of YouTube, that would be absolutely fantastic. There'll be a link in the video description. Just head over there, hit subscribe, and that is all you need to do. But without further ado, let's get into today's video. Oh, and don't forget to subscribe to me if you're new. Thanks. Hello ladies and gents, welcome to another repair video. Today we're going to be working on this Nintendo Switch which has been sent in. And this particular Switch has been sent in because it has no power. So this has been sent down from London. So we can take a look at it. And the first thing I want to do is I want to plug in a USB amp meter so I can figure out what's actually going on with it. So I'm going to grab a USB. Plug it in. And let's see what kind of current it's drawing, shall we? Okay, so it's recognised the USB. And we get 0.42 amps. Which would appear to be a normal current draw. However, this is another one of those pattern recognition things where it's drawing 0.4 to 0.45 amps, which appears to be slow charge, but in actual fact it's probably got an issue with P13USB, which is a common knock-on effect of having a damaged port, because P13USB is directly linked to the USB-C port. P13USB is the HDMI IC for the Nintendo Switch, and it controls video output, so it controls stuff like docking and some of the USB-C circuit as well. So let's take it apart, see what we can do with it, and see if we can get this thing working again. Now the one problem with having a short on the P13 USB would be that sometimes it can cause an issue where it will basically short out the CPU. So what I'm going to do, I'm going to take it apart, I'm going to run some tests, and then I'll see where the short is. If there's a short on P13, I'll remove the chip, and if there's a short after I've removed P13, then it'll be a no fix, because then it'll have that will basically be a short on the CPU. Let's hope that's not the case. Let's hope it's just a case of it's a bad chip. But we do have current draw, which means the USB-C circuit is working. But there's an issue somewhere along the line. So the port itself has never been changed, so I'm going to inspect the port under the microscope and see what the situation is with that, see if we've got any damage there. Right, we do have damage to the port. It's very hard to see, but there is damage there. So just here, there's two pins in the middle that are sticking up. So there's pins in the middle sticking up, and also around the edge it looks like it's hard to tell, but it's either a little bit of liquid damage, not a lot, but a little bit of liquid damage, or corrosion, or dust, sorry. Yeah, I think it might be dust actually, might not be liquid damage. So that side seems fine, that side seems nice and flat. But this side, there is definitely a couple of pins sticking up there, so they should be sitting flat inside their little grooves, and they're not. I'm not sure how well you can actually tell on the camera, but there's definitely some damage to a couple of those middle pins, and that port is going to need replacing. So I'm going to do that first. I'm going to replace that port first. So to replace the port, I'm going to set my airflow to 50%, and I'm going to set my hot air to 480 degrees, and I'm going to remove the port without a nozzle, and all I'm going to do is just heat up the area using hot air. So I'm going to put heat directly onto the port itself. So every couple of seconds I'm coming in with the tweezers and just tapping the bottom of the port. And what that's going to do is it's going to tell me when this is ready to come up. I can also tap the side of the port. Just give it little nudges here and there. Almost ready. So you'll notice even though the port moved, I've not lifted it off yet. And I'm not lifting it off until it basically wants to come off on its own. And by doing it that way, it's going to make sure that I don't damage the traces underneath. Because I know 100% that the traces are melted and ready to come off before the ground legs. And by doing it that way, I'm not going to damage any traces. Next, what I want to do is just replace the solder that's on there at the minute with fresh leaded. So leaded solder is going to be a much lower melting temperature when I put the port back on. So I'll replace the solder by just running the iron across it with some fresh leaded solder on the edge of the iron, or on the tip of the iron. So I'm going to add some flux. And you'll notice I'm going with the direction of these pads. And then I can go round in a circle. Making sure to not put any pressure on the pads. And again, it's going to prevent me from damaging them. Okay, let's clean up. Alright, so those pads do need a bit more solder on them. But now that I've got the lead-free solder off there, I can go from side to side to put solder onto them. There we go. Just drag across and the solder will follow the iron onto the pads. So the way that I install the new port is I'll hold the port itself in a pair of tweezers like this. But I'm not going to put it near the motherboard yet. I'm going to heat up the area first. I'm going to melt the solder and then I'm just going to drop the port on That's not quite in line, so I'm going to reflow it quickly, and then I'm just going to nudge it to the one side. Press and hold, move the air away, and let go. And if we zoom in on this now, you see that's beautifully lined up. And all of those pins should be soldered. And they are. Perfect. The perfect port replacement. No melted port. Every pin is soldered. No mess. No problem. Beautiful. That's a port to be proud of. So if we look up the top of the board, so we come from the port. So just here. Come from the port. And if we move on up, we come to this chip here. This is M92T36. So this is the power management IC for the Nintendo Switch. This controls pretty much all power going into the board when it first goes in. And one of the common problems when we get a damaged port is this chip will fail. So the way we're going to check that is we're going to go into continuity mode. That's the mode that's going to beep when we complete the circuit. And we're going to put one probe on ground. I'll use the ground shield. And we're going to test these caps here, these caps here, this cap here, and these caps here. So no short, no short, no short, no short, no, no. And that one there is shorted. So this cap here is directly linked to P13 USB. So that cap there is where the power will go out of the M92T36 and then it will go through to the other side of the board and it comes out at P13 USB. And P13 USB is on the back of the board, just here. And the good news is it doesn't look like the chip is completely burnt out, which means that it should be okay once we replace this chip. Fingers crossed. We can't guarantee, but fingers crossed. So let's check this cap, and this cap is going to be shorted. There you go. So that cap is shorted. So it's P13 USB which has failed, which is exactly what I expected when I plugged it into the USB ammeter. So I'm going to get P13 USB removed, and then I'll check that cap again for shorts. If the short is gone, then I'll just replace the chip, and if the short's still there, then it's bad news. So there's the chip removed. And doesn't appear to be any bridge pads, so we can just go ahead and test. So one probe on ground again. Beautiful. Short gone. If we turn the board around and we take a look on this side now, if we remember, this side of the board had a short on this capacitor here, and as you can see, that short is now gone. So Let's flip the board around. Let's pop a new P13 USB on. And we'll see if it fixes the issue. So I'm going to heat up until that chip basically locks itself into place. It's not soldered yet. But now I'm going to add some flux. I'll basically just tack the chip down first. Add a bit of flux afterwards. And then this chip will basically solder itself. Should start to throw itself into line in a second. There we go. Beautiful. Right, so while I'm on the back of the board, I'm just going to clean up these ground legs on the port. Just to make sure that this port stays nice and secure. There we go. So that port should be nice and secure now. So what I'll do now is just clean up, get rid of the flux that's around the area, and the flux that's on P13 as well. And we should be good to test. It should be cool enough to test it by then. Alright, so let me just get the rest of the board cleaned off and then we'll give it a test and see what happens with it. Right, so let's get the essentials installed on this. Let's connect up the screen and the backlight and the battery, and that's pretty much all we need to test. All we want to do is test at the moment. We don't need to see anything else working. Right, so like I said, essentials only. So we've got the power button, we've got the LCD, the backlight and the battery, and that's pretty much all we need for testing, just to see it working. Right, so ignoring that, that's just a bit of gunk off there. I do give them a clean before they go back. Let's see if we get anything different now. So same charger, and it might help if we actually got that in line. There we go. There we go. There's the charging symbol, and this console is fixed. So that's going to take a long time to charge up because this battery is going to be very dead. So like I said, while I'm waiting for that to charge up, because this is charging now, let's just check it on the other side of the port actually, make sure that we're charging on that side. And we are, so both sides of the port are working, the port is installed correctly. So while we're waiting for that to charge up, because basically it's going to take a while, so while we're waiting, to save a little bit of time, because this is probably going to work now, this is probably going to work absolutely fine, I'm going to get everything else connected up. The one thing I am going to do is I'm going to disconnect everything while I connect up the touchscreen, because we don't want to be blowing the chip. There we go. Right, so that's fully reassembled, so I'll just need to wait for it to charge now. And once it's charged enough to turn on, we can give it a test. Hopefully we're not going to have any more problems with it, but sometimes it comes back and bites me in the backside. But never mind. Yeah, so that was just completely and utterly dead, but by putting it onto the 15 volt charger, it charges quicker. Right. Touchscreen works. Good. So the touchscreen's working fine. Right, so let's test Joy-Cons. That Joy-Con works. That Joy-Con works. Or at least it picked up. It's probably dead. There you go, paired. Yep, so Joy-Cons work. And the controllers are charging, which means the fan also works because the circuit's linked. So I have a set process on what I'll do for testing everything now. And the next thing I want to test is a game. So I'll make sure that the game card slot works. And it does. Crash Insane Trilogy. And then we go to settings, data management, software, and we find Crash Insane Trilogy. Delete that software that I've just installed. The only time I don't delete that is if it's already installed on the system. Always delete the software you install for testing. Let's test the internet. I'm going to scroll down to my connection. There is a hidden message in the Wi-Fi password. So if you're new to the channel, there is a hidden message in that Wi-Fi password. Boop. There we go. Test connection. It's going to limit me to 40 megabits per second. There we go. Software limitations. So internet works. So all of that seems to be checking out. The last thing I need to do is test it on the dock. So I need to make sure that it's going to dock. If it docks, it means the port's installed 100% correct. And if the port is installed 100% correct, it charges and everything else is testing fine as it is, then we're good to go. So I'm going to pop this on the dock. And there we go. So that's docking absolutely fine. So as you can see, this Nintendo Switch is now working, and this customer is going to be one happy little bunny. So let's just summarise on this then. So this console was sent in because it had no power, and by taking a look at the USB-C port under the microscope, we did determine that a couple of the pins in the middle were damaged. So after replacing the port, we also diagnosed that there was a short on the P13USB chip, which is the USB-C video output chip for the Nintendo Switch. But by replacing that chip, we were able to successfully restore the circuit and get this Switch working again. But that's going to be it for this video. Thank you very much for watching. If you do have any comments or questions, leave them down in the comment section down below. I will always do my best to get back to you. And if you do want to organise a repair, contact details will be in the video description. If you like what you see here and you want to see more repair videos where I fix mainly consoles, but sometimes I do other things too, be sure to hit the subscribe button and turn on the bell notifications so that you're notified every time that I upload. I also now have channel members where for as little as £1.99 per month you can support the channel and support what I do here, and all channel members get early access to my videos. But that's going to be it for this one. Thank you very much for watching, and until next time, see you later. Bye for now.